Okay, you guys, so in this next part of the module, what we're going to be doing is actually reversing ourselves. And what I mean by that is we're going to be using the inverse function. So let's go back to our review. It's been a while of our college algebra, right? An inverse function, first of all, we have to have a one-to-one function. And these, we'll talk about the one-to-oneness of these in another chapter. But there is a workaround when things aren't, which is why they exist here. And we've already seen that they exist by just looking at our calculator, right? There's the inverse function of sine, there's the inverse function of cosine, and there's the inverse function of tangent. So we do know that they in fact exist. And then remember what happens here, if I have a function, any function one-to-one that, if f of 3 is equal to 8, then the inverse basically reverses that, right? You take the output of the function. If it becomes the input of the inverse, it produces the input of the function. Hopefully that, so basically the input and output are essentially reversed. So that's what's going to happen here. So what we're going to be doing is trying to find an angle within the first quadrant. So that's the good news here. We'll talk about other quadrants later. But I've got to find an angle where the sine is equal to 1/4. Now the reason why this was important is, remember, sine is positive in quad 1 and in quad 2 by the theory that we've done. So we're actually expecting two answers for this equation, but we're only going to be interested in quad 1 answers, and the calculator is actually limited. The technology is great, but the calculator actually only gives us the answer in quad 1. And so we're going to have to use our reference angles to find the one in quad 2, but we'll do that later. Right now we're just introducing ourselves to the calculator, and so we're just going to do what the calculator simply does for us. So just be aware of that. I'll kind of make that reference frame for the next problems, and then we'll just press some buttons. But there's more going on here. Again, the technology is a wonderful tool, but it's limited. You have to understand what you're doing to get the most out of it. So hopefully you're learning. So using this theory here about inverses, right, if the sine of my input is equal to 1/4, that means the inverse sine of that output is equal to theta. And that is how we find our theta. So again, that would be the exact answer, right, if I was asking for an exact answer. But if we're asking for an estimate, I'd go to my calculator. I need to invoke the inverse sine, so it's a secondary feature. So I'll go second and sine, and there's the inverse. And then we have 1 divided by 4. Close the parentheses. Remember, let's make sure I'm in degree mode, by the way. Yeah. So I'm still in degree mode. So when I press enter, there's your degree. So we're talking about 14 point, what is that, 4775 degrees. All right. And again, this is an estimated answer now because we can see there's a lot more decimals. So that's how you basically do that. So hopefully that's a good review of our inverse function concept. So the next one, right, the cosine of the input angle gives us the ratio 2/3. So to reverse that, the inverse cosine of 2/3 would have to be equal to the angle. So again, there's your exact answer, right? But to find an estimate, we'll go to our calculator. Let me bring it over here, all right? And we'll just press second, inverse cosine, right? And then in this case, we have the ratio 2 divided by 3. Close parentheses, press enter, and voila, we got that our theta is estimated to be 48 point, what is that, 1897 oops, 1897 degrees. All right, and so there you have it. Again, the calculator is limiting our answers to quad 1, but if we really think about this, right, where is cosine positive? Well, it is positive in quad 1. There's the answer. But there also is an answer in quad 4, because that's another quadrant where cosine is positive. So more on that later. Again, I'm just planting that seed that even though we have the technology, that's not the end of the story. You guys really have to understand that as we move forward. There's actually an infinite number of answers here. Remember, we have everything that's coterminal that as answers. All right, and then we have another one in quad 4 that'll actually work. So more on that later. Calculator just gives us what it's going to give us. Last but not least here, we have the tangent of theta equals 6/5. All right, and so basically, again, using the theory, if the input gives us this output, then the inverse function takes that output and gives us the input. And so again, there's the exact answer. Turning to the calculator to bust that out, right? We are invoking the inverse tangent. So I'll press that. And then we're talking about the fraction 6 divided by 5. Press that. And it looks like theta is 50.1944 degrees. And again, that's a quad 1 answer. That makes sense because we know tangent is positive in quad 1. But then sneakily, there's a quad 3 answer, right? Because that's another angle. That's another area where tangent's positive. And again, we'll talk about that later, just planting that seed. I think I'm good to go. Let's keep on going here. So the next round, right, what's different about this is rather than the sine and cosine and tangent being equal to a ratio, right, our sine, cosine, and tangent are equal to a decimal. But that's okay, right, because what are fractions? They're decimals. What are decimals? They're fractions. So nothing really changes. Don't get too scared if there's not a fraction there. It's the same process. So if my input of sine creates that ratio or that decimal, that means that the inverse sine of that decimal is going to be our angle theta. All right, and so there you have it. So that means putting that into my calculator, right? That's the exact answer, by the way. Putting that in my calculator, the inverse tangent of 0.123456, right, looks like it's 7.0916. And degree mode, right? So we're talking degrees there. So there, all right? So this one, again, if the angle input of cosine gives us that decimal, that means that the inverse cosine of that decimal, right, is going to be equal to that input theta. So there's the exact answer. To estimate it, we'll go to the calculator, and we're going to look the second inverse of 0.98765. Press enter, and it looks like it's giving us 9.0140, and that's degrees. Okay, so there you have it. One more time. Let me move this over here. Again, if the input of tangent creates the decimal point 0.8, then the inverse tangent of 0.8 is going to give us the theta we're looking for. So the estimated answer, the inverse tangent, all right, of 0.8, close parentheses, enter. It looks like it's 38.6598 degrees. All right, so there's your first introduction to our inverse function. Up to this point, we really don't have any idea what the angle is, but because of our inverse function, we can actually do that. But again, it is limited. It's only giving us quad 1 answers when in fact we know there's other answers within the first rotation. So there's more to this story, but that's a great introduction to get you going to at least get one angle that actually works, right? The one in quad 1. So how about we do this? What I'm going to do, we're already 8 minutes into this, and we have to figure out how to, right, because there's an inverse sine, inverse cosine, inverse tangent on my calculator, but there's not an inverse cosecant, inverse secant, and inverse cotangent because those aren't on my calculator. So that's going to create some more math, right, some more algebra for us to do. But I want to cut away to another video and start fresh. So I'll see you guys then.